Hi, welcome. First, thank you so much for deciding to watch my talk about my research, which uses osteometric analysis as the way to estimate and reconstruct the species and morphological variation at the site Los Batanes in southern Peru. The presentation is structured in two ways. In the first part, I will quickly walk through some backgrounds necessary for understanding the bigger picture of my research. And in the second part, I will particularly address my research questions, my data, and some discussions about the implications of those results. So part one. The site where I worked at and collected data is in the coastal desert of southern Peru. It is located in a valley called the Sama Valley. Since 2017, a research group led by Dr. Baitel from Anthropology Department at Washington University and Peruvian archaeologist Arturo has been conducting archaeological surveys, excavations, and laboratory analysis in the Sama Valley. And since 2018, they have been excavating the site called Los Batanes. Los Batanes, as far as we know, is a site with perimeter walls. We found various types of housing structures, patios or plazas, as well as cemeteries. The site is roughly dated back to 1,000 years ago, and its occupation span is probably pretty short, less than 100 years. The site was probably founded by a group of people whose material culture is associated with the Tiwanaku state in the South Central Highland, during the time when the state itself started to collapse due to various environmental and social factors. Nevertheless, residents at the site, Los Batanes, were very resilient and adaptive to the change associated with their move to the Sama Valley, as we see in the consumption of ecological resources. They ate maize and quinoa, they hunt shellfish, and they raised lots of animals, in which the majority is the South American camelids. Now, some necessary background about South American camelids. They share their ancestry with camelids in other parts of the world, but only 4 species of them live in South America today. 2 of them are wild species, the guanaco and the vicuña. 2 are domesticated species, the llamas and alpacas. Llamas and alpacas were domesticated by 3,000 years ago. One major outcome of the domestication is the expansion of the possible habitat zones as part of human intervention. The wild progenitors, as well as the wild species today, restricted their natural habitat in the highlands and in the mountains. Of the domesticated species, alpacas are selective in choosing their habitats. They still prefer highland environments. Llamas, on the other hand, are more adaptive to different ecozones, especially that they have been brought to the coastal desert as early as 2,000 years ago. Last but not least is the functional difference between llamas and alpacas in the economy. Specifically, llamas are larger in body size, so they are often used as the pack animals to carry things around in the ancient Andes. Alpacas are smaller in body size. Their fleece is very soft, so they were raised as great sources of fiber for textile production. Now, a little bit of summary of part one. We know that Los Batanes is a newly established site in the Sama Valley on the eve of Tiwanaku collapse. The residents at the site managed to get access to various resources from both the highland and the sea. They make their own ceramic type, but they haven't lost their connection to the broader cultural sphere. Also, we know that Camelid remains predominated the zooarchaeological assemblage of Los Batanes. And very importantly, we notice body size and species as potential indicators of Camelid use in the past. Therefore, I designed my study to answer the following questions. Which camelid species or morphological types were presented at Los Batanes? And how can it inform us about the economic and social roles of camelids at the site? The paradigm I use to address my research question is through osteometric analysis. It is based on a working assumption about the correlation between dimensions of a particular bone element to the size or weight of the animal. The dimensions are quantitatively assessed by taking measurements on the bones. And those correlations are usually established with reference animals whose biometric information are recorded. With this paradigm, I measured 42 camelid first phalanx from the zooarchaeological assemblages of Los Batanes, following the selection and measuring criteria outlined in one of the foundational work in the study of camelid osteometry. I chose first phalanx as the element of study because of the generally established correlation with camelid species and morphotypes. Then I analyzed the measurement data with multivariate statistics. For each phalanx, I will identify it as either from the front limb or the back limb. Each phalanx is associated with a distinct specimen number, and for each specimen, 5 measurements were taken based on the criteria outlined by Kent 1982. All measurement results are represented in millimeters. Here is the bivariate plot of variable M2 and M3. Each black dot here represents one specimen. It's very clear visually that there are at least 2 morphological groups, one at the bottom left and the remaining skewed towards the upper right. If we overlap this plot with reference dataset from other literatures, we find that the 2 specimens at the lower left are morphologically similar to that of alpacas and vicuñas, while the rest of the specimens are in the range of llamas and guanacos. Although the variation is not captured by any morphological range of a single species based on the reference datasets. Other statistical methods present relatively similar pattern from different perspectives. For example, the discriminant analysis suggests the presence of small-sized camelids as well as the large-sized camelids, with the large-sized camelid predominating the samples by 4:1 ratio, roughly. Although we noticed at least 2 morphological groups with bivariate plot, which included only 2 variables, the principal component analysis, which takes into account all 5 variables but reduces them to 2 most explanatory components, suggests probably a presence of 4 distinct morphological groups in the samples. Therefore, all statistical methods review morphological variation of camelid population as Los Batanes, as 2 individuals identified morphologically resembling modern alpacas and vicuñas. Remember that alpacas don't naturally live in lowland deserts. Therefore, the result may indicate specialized herding of alpacas at Los Batanes for the extraction of camelid fiber. Also, some specimens are super large in size, way larger than the range of modern llamas as shown in the reference datasets. This pattern is probably the result of castration, which anthropogenically increases the body size of llamas for the purpose of using them for as the llama caravans. Therefore, residents at Los Batanes kept both llamas and alpacas around the site, producing textiles with llama fleece or alpaca fleece and participating in caravan economy. My result speaks to a highly adaptive community for whom South American camelids were the key drivers of their social, economic, and cultural life. Thank you. Thank you all who make this research possible. If you have questions, I would love to share more about the research than what is presented here. And also, if you are interested in excavations at Los Batanes, definitely get in touch with Dr. Sarah Beitel. She's super nice and approachable. And again, thank you for watching. Hope you enjoy it and have a good day.